Morning students, today topic is lesson number 12, equivalent statements. Logical statements, equivalent statements. The result of left hand side and the right hand side are identical. Identical means the same result. Then the given statement is equivalent. Now EX number 12.2, sum number 8 show that number 1, negation of P and Q is equivalent to negation of P or negation of Q. This is the both statements. Left hand side one statement, right hand side another statement. Now arranging these two. Truth table for negation of P and Q is equivalent to negation of P or negation of Q. There are two postulates P and Q, therefore take P and Q. True, 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 false, false, true, false, false. Next, and symbol is given, P and Q. So T and T is true and true means true. True and false means false. False and true means false. False false means same. False false means true. Next, false and false. False false means false. False false means false. False and false is false. Next, negation of P and Q. Negation of P and Q. True means false. False means true. False means true. False means true. Negation of P and Q. Negation of P. Take first column. True means false. False means true. False. Next false. Next true. Next true. Negation of Q. Take second column. True means false. False means true. So false. Next true. Next false. Next true. Next negation of P and or symbol is using negation of P or negation of Q. F means false false. False or false is false. False and false is false or true is true. Next, true or false is true. True means true or false. True is true. Now the fourth column and the seventh column results are same, identical. Therefore the given statement is equivalent. Column number 4. Column number 7. Column number 4 and 7 are the results are identical. The results are identical. Therefore the given statement is equivalent. Is equivalent. That is negation of P and Q is equivalent to negation of P or negation of Q. Next, negation of P, the conditional Q is equivalent to P and Q. Truth table for negation of P implies Q is equivalent to P and Q. There are two postulates P and Q is given, therefore true true, true false, false true, false false. P conditional Q, conditional statement is Q. So T into T, T implies T is T, T implies F is F, F implies T is T, F implies F is T. Next, negation of P implies Q. True means false, false means true. False, true, false, false. Next, P and Q. Take first two columns. T and T is true. True and false is true and false is false. True and false is false. Next, false and true is false. Next, false and false is false. From the table, fourth column result FT, TF, FF, FF. Fourth column result and fifth column results are not identical. Therefore, it is not equivalent. The fourth column and fifth column results are not identical. Therefore, it is not equivalent. It is not equivalent. Next, prove that Q implies P is equivalent to negation of P implies a negation of Q. The table for prove the table for Q implies P is equivalent to negation of P implies a negation of Q. Now there are two postulates. One is P, another one is Q. So P and Q are the postulates of this problem. So we have to take TT. TT means true true, true false, false true, false false. Now Q implies P. Q implies P. T true, 2 implies true. So T. F implies T is T. T implies F is T implies F is F. Next, FF means a T. Now negation of P. Take first column. True is given, the negation of P is false. False is given, the negation of P is true. Negation of P is true. Okay. First false, second false, third true, fourth true. Negation of P. Take second column. True, false. False is given, therefore true. Next, true, false, false, true. Negation of P implies negation of Q. P implies Q. F implies F. F implies F is T. F implies T is T. Next, T implies F is F. T implies T is T. So the third column result and sixth column results are identical. The third column and sixth column results are identical. Therefore, the given statement is equivalent. Therefore, Q implies P is equivalent to negation of P implies negation of Q. Then already done. So 11 show that negation of P implies Q is equivalent to P implies and implied by, or P if and only if negation of Q. Truth table for negation of P implies Q is equivalent to P if and only if negation of Q. There are two postulates. One is P, another one is Q. So P and Q are the two postulates. Take true true, true false, false true, false false. P implies Q means conditional statement true into true, or true implies true is true. Next false, next true, next true. False implies false is true. Okay, negation of P implies Q. Take third column. True implies true means negation of true is false. Negation of false is true. Therefore, true false, false true, true false, true false. Next, negation of Q. Take second column. True negation of true is false. False negation of false is true. So false, next true, next false, next true. Now P implies and implied by negation of Q. So take this and this. P implies negation of Q. First column and fifth column. First column and fifth column. True if and only if F is false. True if and only if means false. Next, true if and only if true is true. Next, false if and only if false is true. False if and only if false is false if and only if false is true. Next, false if and only if false is true. Implies F is F implies and implied by F is F. Next, F implies and implied by T is F. Okay. Now F, T, F, F. Here F, T, F, F. So fourth column and sixth column. Take the column number fourth and sixth column. Results are identical. Therefore, negation of P implies Q is equivalent to P Q. Next, prove that P implies negation of Q or R is equivalent to negation of P or negation of Q or R. There are three postulates. One is P, next one is Q, next one is R. So T, T, T. Next one F, one false. T, T, F, T, F, T, F, T, T. Next double F, 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 one T. Next F, T, F. Next F, F, T. then F, F, F. Okay. Now negation of Q. Take second column. True. Negation is false. False negation is true. Therefore, false, false, true, false, true, false, true, true. Next, negation of negation of Q, R. Take third and fourth. Symbol is R. So T or F is T. F means F. Next T. Next T. Next T. Next F. Next T. Next T. Next P implies negation of Q or R. So P implies T means T. TF means F. TT means T. FT means T. Next TT means T. FF means T. Next FT means T. FT means T. Next negation of P. Take first column. True means false. False negation is true. So false. Next false. Next false. Next true. Next false. Next true. Next true. Next true. Now last and fifth column. R symbol is using. We get negation of P, negation of Q or R. So take this and this. So fifth column and seventh column. R symbol is using. T, F means T, FF means F. R symbol is F. Next TT, no, TF. R symbol is T. Next T team, TF team, F team, T team, T team, T. Now take last column and negation of Q or R. T, F, T, team. Next T. Here check. Sixth and 1, 2, 3, 4, 5, 6. Sixth and eighth column. T team, FF, T team, T team, T team, T team, T team, T team. So 1, 2, 3, 4, 5, 6. Sixth column and eighth column results are identical. Therefore, it is equivalent. The column number 6 and 8th column results are identical. Then identical. Therefore, negation of P implies negation of Q or R is equivalent to negation of P or negation of Q or R. Hence the result. The homework number 1. So that P implies and implied by Q is equivalent to negation of P or Q. and negation of Q or P. Number 2, show that negation of P and Q is equivalent to negation of P or negation of Q. Next, sum number 3, show that P implies Q is equivalent to negation of P or Q. Any doubt, reply the message. Thank you.